Okay, Alan, I can't hear you, but can anybody hear me? Let me know if anybody can hear me. Um,
I can hear you.
oh, great, great. Okay, cool.
Right. So over to you. Share your content and we can start.
Okay, so hi everyone. For those watching me, good evening, good morning, good afternoon. So we'll be speaking on introduction to DAX in Power BI, and we need to understand the concept of DAX. A whole lot of people say, "Oh, I hate DAX." They just don't like DAX, but they love the visualization side of Power BI. But the DAX aspect is where the challenge start from, and that is where people have challenges, and we're trying to see the ways in which we can help people come into DAX easily so that they can create better analysis, because DAX helps you to be flexible and to be able to do stuff with DAX, with numbers, with your tables, or with your data itself. So that is the whole idea of DAX. So definitely somebody want to ask, what is DAX? What is even the full meaning of DAX? So, but we'll be looking at that in this section, and hopefully I have like 35 40 minutes more, and we should be able to cover something as we go on. Okay, so this is me. My name is David Abu. I work with Microsoft as a cloud advocate for Power BI, and also I I have the Power Platform Nigerian group, in which I help to manage here in Lagos, Nigeria. I'm in Lagos, Nigeria. So one of the things that has helped me over time is because I love to share the things I learn, and this is one of the things that we're going to do today. We'll be learning Power BI. Yeah, DAX, Power BI. So what is DAX? DAX is data analysis expression. So we are trying to express ourselves more with data. So DAX started in Excel. So there is DAX in Excel, and you know that there is Power Query and Power Pivot in Excel. So it was being combined together to give us what we have, the Power BI. So DAX is the language of Power BI, as M language is the language of Power Query. So Power Query is the ETL tool. The ETL tool, we call it the extract, transform, and load tool, that helps you bring in the data set, and you clean the data set up. You transform it into the rules of data, structured rule of data that we have, and then you bring it to Power BI to analyze. But when you start analyzing, there are some things that you want to look for that might now be hard for you to look for, but you need to look for them, and that is where DAX comes in. You need to start writing some codes to enable you to express yourself with the data set, and that is data analysis expression. It's as simple as that. Yeah. So now, how what do you use DAX for? Now you use it for measures. Now measures are the things that you want to use. Let's say you want to sum, you want to count, average, you want to be able to filter some data out and make sure that, oh, these are the only set of data I want to work with, or some things like that. So measures are the real codes that you want to write to analyze. Calculated columns are different columns that you created yourself inside Power BI. So that those are calculated columns, and calculated columns are inside the calculated tables. Yeah, they're inside calculated tables. And so any table that you bring in into Power BI, and let's say you want to add a little bit of column, you want to add some columns to understand some column, you can do that. And that is calculated columns, or you can create a whole calculated table. And calculated table, an example of calculated table is dates. So a whole lot of people prefer to create a date table, a calendar table, They call it date table, they call it calendar table. So you want to be able to create it so that you could be able to analyze your report one way or the other. And you remember data, DAX is data analysis expression. You're trying to express yourself. So everything that you use DAX to do is to just express yourself. It's as simple as that. Just express yourself. So how do we look at a data set and start expressing ourselves? Now, every measure, calculated column, calculated table have the same syntax. So DAX has the same set of syntax. It's just for you to understand how you can understand what you're trying to do, then how you can replicate it into the syntax. So now, the first thing that you want to look at is the measure name. So now, when you look at Excel and you're trying to do a sum, you just write equals to sum and you pick the columns that you want. But it doesn't work that way with Power BI. Power BI, you have to give it a name. So you have to give it a name, a house or a room. So you have to give it that name. So what is our name? We call it, like, let's say, measure name. So that's what we call it, measure name. So the next thing is now your equals to. So you need your equals to sign so that it gives birth to the next thing, which is now the function that you want to use, just like Excel. Just like Excel, equals to, that means that you want to use a function next. So now that function is what we call the DAX function. So the first thing is that you want to give it a name. The second thing is that you are writing your equals to, and now the DAX function. So now, when you write the DAX function, you have to reference something. You have to reference something in your data set. Is it that you are referencing a column or you are referencing a table? You are referencing a column or you are referencing a table. So right now, this sales is called table name. The sales is called table name. But there might be a column that you want to reference, and that might be the column name. So this completely is what we call the DAX syntax. So DAX syntax is you starting from your measure name equals to the DAX function that you want to use. And now your DAX function will ask you that, oh, I want to reference something. What am I referencing? Oh, we are referencing, let's say, the sales table, then the revenue column, and that is where we are going to. So these are just, I'm just trying to give you a little bit breakdown of before we now go into the Power BI itself. Okay, so let's go to Power BI. So, and let's see what we can do in Power BI. So let me see if you can see my screen. What, can you see my screen? I hope you can see. I'm still sharing. Oh, sorry, I'm not sharing. Okay, sorry. So let me share my screen back. Okay. Okay, cool. Now, so I want you to see my data set first. So my data set is important for you to see so that you can you be able to understand what we are trying to do. So if you can look at it right now, we have the customer, we have the sales. This is the adventure work data set. So you're going to see it on Microsoft Learn. So it's so easy for you to see. So we have then the products. We have products. We have, these are the different products that we have. So if you can also look at the different tables, we have customer, date, products, resellers, sales order, sales territory. So different dates. But the major ones that we'll be using for this analysis is, there are two. We have the date and also the sales. So if you look at the dates right now, you can see the dates. So we have, these are the different columns that we have in the dates, and we want to just understand how can we improve on these dates, if we want to improve on it, or how do we analyze using dates. And the next one that we want to look at is sales. So definitely we understand what a sales table is. So how do we work with a sales table? So, and this is sales. And if you look at it, we have the order quantity, we have the unit price, we have the estimated amount, we have the cost, we have the product cost, we have the sales amount, we have the unit price. So now when we go into analysis, then we'll start looking at the things that we need to look at. So now let's go into the analysis itself. Now, if we look at this right now, this is a simple report, just a simple report. Um, and I click 2017, you're going to notice it. It's changing 2018. It's just simple report. But my line manager, let's assume that my line manager is Alan. And Alan says, oh, David, I want to be able to see a quarter analysis. Then there will be a big problem because I will start thinking that, okay, quarter analysis, my date does not have quarter. So if you look back again here, you're going to see it here that my date does not have any quarter. So how do I pick? How do I pick it? So there's a big issue right now. Date, no quarter. So, okay. So now we are going to look at something. And that's what we are going to look at right now is this. So now let's go back to the data set. Now in the data set itself, so let me reduce my screen a little bit. Okay, good. In the data set, so let's look at this data set. We don't have quarter, but we need to create quarter so that our data will be able to do a data set, a quarter analysis. Now, and this brings me to something that we call the calculated column. We need to calculate a column. We need to add it into our data set. So now, how do we create a calculated column? So if you look up here, you're going to see something called the new column. New column. If you want to create a calculated table, you have new table. But if you want to create a column, you click on new column. So I'm going to click on new column. So if I'm going to click on new column right now, now remember what we said um, when when you're looking at my slides. We said something like the first thing in syntax is the name. So what is the name we're giving it? You're writing what? Quarter. That's what you're going to write, quarter. Now after that, we want to be able to create something which is quarter, that is the name, equals to then the function. Now, which function helps us create formats? I mean, quarter. That just it, quarter. So if we look at quarter, is there quarter? Yes, there is quarter. So that is just function. So it's just like Excel. It's just like Excel. So, oh, there is quarter. So let's try it if it's going to give us the results of what we want. So I'm going to click quarter. Now, when we click quarter, we have to reference something. So what are we trying to reference? Which column are we referencing to give us quarter? Which type of quarter we're looking for? So definitely we're looking for date. You have to use date most of the time. The column called date. So I'm going to type date, and I'm going to pick dates. I'm going to close it, and I'm going to click enter. So let's see if it's going to work. Good. You notice it says 3333. So then you need to be sure if you get it right. So if you look at your month name is July. So definitely it is quarter 3. Your month number is 7, which is quarter 3. Makes more sense. But now you want to say, oh, David, can we put it in a way whereby we have Q and 3 together so that we know that it is Q3, Q4, Q1, Q2. So we might put it that way. And just the same way as we have in Excel, we can just put this double quote. We have capital letter Q, double quote, and we put the and space, and we click enter. So now just let's see what it brings. So good. So now we have this Q3. So calculated column has given us that option to be able to do this. Now, so Alan, if there are questions, please let me know. I might not be able to see the screen right now. So now we want to be able to do that because my line manager have said, oh, I want to see the quarter analysis. So now I'm going to go to I'm going to pick a graph. So I pick the line graph, I pick my quarter. Then let's say I go to sales and I pick my sales amount. So now if you notice that we have 2014 that we're clicking alone, but when we click on 2018, you're going to now see Q1 to Q4. So we can also rechange it. We can change it ascending way so that we have here Q1, Q2, 3. So it just went up, and we can see 2019, and we can see 2020. So is like that. So that is what calculated column, calculated table has given us the option to do. So and that is just how it works. So now the next thing that we want to go into is anchor measures. So we've dealt with calculated tables, calculated columns. We want to go into anchor measure. Now, this really is the major one that everybody needs to understand. So now, what are anchor measures? Anchor measures are the pillar measures. So if you have um, a measure that you know that is so important for you, that that is the measure that you want to as we call it, slice and dice by different categories, by different categories, by different items, by different products. So we have, let's say, oh, give me category by product, category by sales amount, give me product by sales amount, give me month by sales amount. You understand? Anything like that, just like revenue, like cost analysis or revenue analysis. That column itself, that column is so important. And that is your anchor measure because it's so important to you. So that metric is your anchor measure. So for us right now, if you look at this right now, we have sales amount, we have extended amount, we have order quantity. We can use any of them as our anchor measure depending on what you're trying to do. So for us right now, sales amount is our anchor measure. Sales amount is our anchor measure. But because it's our anchor measure, the first thing that you want to ask yourself is, okay, what am I trying to solve? I can see my amount here already. So why do I need an anchor measure? I can see the total. What do I need an anchor measure for? So Alan now says, oh, David, or let's say Liu said, oh, David, I need to be able to know our profit. What is our profit margin? So we sold this and this is the cost of the product. What is our profit? So it means that I need to subtract sales from what? From total product cost. That is just what it means. I need to subtract 109 million from, or 109 minus 97. How do I do that? Using DAX. It's going to be challenging because we need to start thinking so many things. So normally I can just go to my DAX, to my tables. Let me go to my tables right now. Let me show you something in sales. I go to sales. I can create a calculated column and say, oh, this column minus this column. It's as simple as that. But it's going to be giving us row analysis, which that is not what we are looking for. We are not looking for that. We are not looking for that. So now what we want to look at is the total. We are trying to look at total itself. We're not looking at row context. We're looking at the column itself. So see what we're going to do. We need to create a DAX measure. So how do you create a DAX measure now? Now in this interface. So this is the first thing that you do. I go to my sales right now. So let me increase it. I go to my sales. I right click my sales. I'm going to seek something called new measure. New measure. I click new measure. So when I click new measure, you're going to see right now that I have, oh, sorry. So I'm currently using one screen right now. So it's making it difficult for me. So sorry. So click new measure. Okay, cool. So now we have this. But what we want to do, remember, we want to be able to subtract. We're trying to look for the profit. So profit means that sales amount minus product cost. It's as simple as that. So what is our measure name? We are looking for profit. So let's put profit equals to sales amount. That is what we are looking for. Sales amount. So I'm going to type sales amount. There's a big problem. There is no sales amount. There is no sales amount. Why? Let me check. Why don't we have profit? Let's just look at product cost. There is none. Do you know why? It's simple. It's because right now, everything in your report right now or in your data set are in implicit measure. You have to convert it to an explicit measure. So what are implicit measures? Implicit measures are measures that are embedded. Power BI gave you to use to do analysis for simple reports. simple reports, simple visualizations. But when you now want to build on it, you want to do DAX, you have to create explicit measure. And your first explicit measure that you have to create is the anchor measure. So now we need to create another anchor measure for sales amount. We need to create another anchor measure for the product cost. Then before we look for profit. Because right now, DAX are explicit measures, but we don't have the explicit measures of sales amount or of product cost. So it doesn't understand what we are trying to do. So we have to give it first the explicit measures of what we are trying to do. So now we're going to cancel this and we do the sales amount again. So let's call sales amount revenue. Let's just call it revenue. Revenue. Now, the sales amount that we're looking for is, that is the column itself. There's a column called sales amount, and we need to be able to sum everything back, give us what we have, the 109.81. We have to do it back. So now, how do we do that? We are going to write sum again, tab. Now, in the tab that immediately we click tab, we open up the bracket. Now, remember when I was explaining the syntax, I said revenue is now called what? It's called the anchor. It's called the measure name. Then we have the equals to sign. Sum is called what? The DAX function. You open your bracket. Now, the next thing is your table name. So what is our table name? Our table name is sales. Then what is our measure name? We are looking for sales amount. So we're going to go to sales amount. See? We close the bracket and we click enter. Now, we have to check if we are right. That's one thing. You have to check if you're right. So how do we check if we're right? So if I come here, the sales amount that we are putting in was the first one that we have, which is the 109. We have to bring in our revenue into this data, into this table to be sure if we have the same thing. Can you see it now? We have the same thing, even though the currency changed. It's fine. I'm a Nigerian, so you're going to see naira there, so it's fine. So now we have this, so it means that they are actually the same figures. Cool. So there's no issue. So let's reproduce that also for product cost very, very fast, so that we can. So I have something called measure name. So let's do that very fast because of time. So we have product cost, and we sum it up again for product cost, sales for product costs. Um, okay. Total product cost. Okay, good. And we do that, and we click that. So now that we have done that, so now we can now look for what do we call to show you we're correct. Let's see. We're going to see that. Cool. So now we have our numbers here. So if you notice, we have 97. We have the 97 million and we have the 109. Now let's minus them. Now we can now minus and look for our profit, because Leo said, David, give me profit. That is what I need. I need profit. So now let's look at the profit. So now you can see how we first converted it into an anchor measure. Then after converting to an anchor measure, we now want to be able to do our what? Our profits. Can you see the way we are expressing ourselves using the data that we have? So our profits, remember, our profits will now be revenue that we have now, which is what we have as sales amount, revenue minus product cost. It's as simple as that. So now let's type revenue. Can you see revenue now? We have revenue minus, is simple, product cost. Products, yeah, product cost. Can you see? Simple, and we click enter. So we need to be sure if it's actually giving us what we want. So right now, if we use our highs to subtract them, it should give us something like 12, I think 12 billion, 12 million. So let's do that. So we bring a card visual. I'm going to bring a card visual here. So we are going to try and look at it and bring in the profits. Cool, simple. That is just it. So that is how you work with DAX using anchor measures. So, and that is how you're doing it. So, because I have like 10 more minutes, so I'm going to go here and we're going to talk about time intelligence. Time intelligence is also one of the things that you use in DAX. So, because people want to understand time, people want to be able to understand time, and that is just, and it's so important for analytics because people want to be understand what did we make last month, what did we make last year, what is the number of people that attended the Azure bootcamp last year, what is the number of people that attended in 2020 or in 2021. how can we think of how can we think of a number that we attended in 2022? It's as simple as that. Time is important in analytics, and that is why we will be using just two. Let's do two, or let's see what time we permit, two or three analytics inside DAX. Now, the first one we want to be able to do is previous month. Previous month. So previous month is so important because what previous month means is that what did we make last month? So we are currently in October, and okay, good. We are currently even in the end of October, and maybe let's say the numbers are coming in right now for the end of the month review, and Leo one says that, oh, I want to know what we made last month. What did we make last month? So last month is September. So if I am in November and she says, what did we make last month? She's talking about October. So if I'm in February, she's talking about January. That's what it means. So if you look at these numbers right now, if you're looking at this table right now, it means that if we say that what did we make last month, it means that when we bring in the DAX into this table, it means that August will actually be showing the result of July. September will be showing the result of August. October will be showing the result of September. And that is it. What did we make last month? Because you are not talking about the present month, you're talking about last month, which is previous month. So let's see how we understand that. Let's see what will help us to do that. Now, to help us do that, we need to understand that we want to do something difficult, and we have to be careful here. Now, we already have something here that is called a filter contest. Now, what is filter contest? Filter contest is whereby a metric has been filtered by something, by category, by something. So now we have our amount here, or we call it revenue, depending on what you want to call it. We have it here, but it has been filtered by two things here. It has been filtered by year, and it has been filtered by month name or month. That is filtered by date. Let's just say it that way. But we want to go there and modify what has been filtered to give us what we want. That's just what we want to do. So now, for us to modify what has been filtered, there is one big function in DAX that helps us do that, and we call it the calculate function. The calculate function helps us modify anything that has been filtered. That is just what it means. It just helps us to modify anything that has been filtered. So let's look at it and let's see how we modify this. So now let's go again. We click on sales, we right click sales, we go to measure, new measure. Now we want to do something called the revenue previous month. That's just what we want to do. Revenue previous month. So let's go on. Alan, is there any question? Let me know, please. Revenue previous month.
Yeah, there's no questions yet.
Okay, thanks. Okay, good. So now we have something called revenue previous month. Now let's see what we're going to do. Remember, I said that we need the calculate function to help us. So I'm going to type calculate, but see, calculate function. Now the calculate function needs a filter contest, and it needs an anchor measure. It needs an anchor measure. So what is the anchor measure that we're trying to look at? Remember, we're trying to say what is our revenue previous month. So what will be our anchor measure, everybody? Is going to be the revenue. It's going to be the revenue. So now I'm going to type revenue. I'm going to put my comma. Now, it's going to ask me that, what am I trying to filter? It's as simple as that. what am I trying to filter? What is the filter thing that I'm trying to do? What am I trying to filter into? What am I trying to modify it into? So now what I'm trying to modify it into is previous month. So I have to look for a function that will give me previous month. That's what it means. I have to look for a function that will give me previous month. So now there's a function called previous. If you look at it right now, you have the previous day, previous month, previous quarter, previous year, and everything like that. So now we are looking for previous month. So I'm going to click my tab. Now in the previous month, let me close my visualization. Don't close, don't close. Okay, good. So now in the previous month, we need a date. And that date is now where we go to our date calendar to pick up date, and we need the date itself. So the date and the date, we call it date. So the date column is what we need. And when we click enter, we should be fine. Good, we are fine. So we need to bring it into the table to be sure that what we are doing is correct. That's just what we need. We need to bring it into the table to be sure that what we're doing is correct. So now let's click on it right now. So I'm going to now bring in our revenue previous month. So cool. So now if you look at it right now, you will notice it now that we have 1423, 1423. You remember, it's going to be telling us the previous month, the previous month, the previous month, the previous month. That's just what it's going to do. So if you want to do previous year, it's just the same thing too. You just remove what I have done using that previous month, replicate it, put it back into previous year, then you have your previous year. But now what we want to do is now the year to date. So that is, I think that will be the last thing I'll be able to teach today. Is going to be year to date. So now year to date is like this. I am adding every revenue or every amount as we go into every month. So if I make 10 naira in January and I make 20 naira in February, in the next month, what I've made is actually 30 naira. My year to date is 30 naira, is what it means. What have we made at the current month? Adding everything to the current month. That's what it means. What have we made? Adding everything to the current month. So now we are going to start adding them one after the other as we go. We'll add them as we go. So now let's pick it up from here and let's see. So I'm going to now click also. I'm going to right click and click on new measure. New measure. And remember, we want to do revenue year to date. Revenue year to date. So year to date, I'm just going to call it YTD. For people in the business, you're going to understand when we say YTD. So now we have two ways to do it, but I'm going to do it in a faster way. So I'm going to do it year to date. Sorry, date YTD. Yeah, date YTD. So now, date YTD immediately is asking us for okay, so sorry, there are two ways. So there's total YTD, there is date YTD. So if you are using total YTD, you have the calculate embedded in it. If you are using date YTD, you have to start with calculate before you do it. So let me see. Okay, I think we might be able to look at the two if possible. But let's go with date YTD first. But for us to do date YTD, you have to start with calculate. Remember the way we do calculate. So we go to calculate. Now remember revenue, pick revenue, comma, then we do our date YTD, then date, we pick dates, dates, then date. It's as simple as that, and we close the bracket. Yeah, close the bracket. So immediately we close the bracket. Let's see if we can look at it and do and see what it brings in the table. So now let's see, clicking, good. So now coming, good. So if you look at it now, 1.423 first, then it adds them. But when it goes to December, it stopped. Then it continued in January and it started adding them as it goes. Start adding them as it goes. Start adding them as it goes. And that is how and that is how you understand. So let me bring this down. Let me see so that you'll be able to understand it. So look at it. 1.4 plus 2.0 gives you 3.4. 3.4 plus 2.5 give you 6 million. So then it goes like that and start going like that and goes and goes and goes. And that is how you do your revenue year to date. So, oh, this is 5:45. Alan, maybe I have to just stop so that I can get question. Hello. Okay, I can hear. I can hear. You're on mute. You're on mute.
I
Yeah,
muted
I
myself
can't
and
hear.
told myself to unmute. Yeah.
Yeah, can everyone hear me?
Yeah, we can.
Yes.
Okay, cool. Yeah, apologies for the issues in the beginning. You didn't get an intro. I was doing a monologue to myself for 15 minutes there with an intro. So apologies when your session started. But you're free to continue if you want to for a couple of more minutes. There is no questions at the moment.
Oh, okay. So let me just
Mm.
let me just finish. Let me just finish what I have. Let me just finish what I have. Okay.
Okay, okay,
So
cool.
um okay. So now we have the revenue and we've been able to do this. So we did it one way. We can do it another way whereby we put it again and we say and we use the total YTD. So now one is just an improved one. So one is improved, one was the outdated one, something like that. You know, in Excel, where you have one function that can do multiple things. So that's just how it is. So we can say revenue YTD. Yeah, revenue YTD. Then we do the total YTD, and now we can just do our anchor revenue, then comma, then dates. Yeah, dates. Yeah, and close the bracket and click enter. So now we're going to look at it now. Yeah, it should give us the same thing. Actually, it should give us the same thing. So if we look at this right now, so if you notice, it actually give us the same thing, just the same thing. So, and that is just how you work with with the time intelligence. You actually use calculate. Anytime you're thinking of, oh, there's a filter context that I have to modify, I have to modify. So, and sometimes you might ask, so at what point do I need to modify something? At what point do I need to modify something? So the point that you need to modify something is when you know that there is already a laid down by default, this is meant for this, but you want to be able to look, you want it to look at another thing, and that is when you start doing all those modifications. You want it to look at another figure or another thing, so that is when you start doing those modifications. So if you can do that, then you start from here, then you start building them up, then you start building them up. So right now, so if you can see my screen right now. So, and also, if you can do that, then you can just notice that there's so many things that you'll be able to do uh, with with Power BI. There's so many things that you'll be able to do with Power BI. So these are also the resources. I hope you can see my resources. Alan, can you see my resources? Alan, can you see my resources?
Yes,
Okay, cool.
I can see it.
Yeah.
Yes, yes.
Yeah, good. So now these are the resources that you can learn. DAX in Power BI Desktop is on Microsoft Learn. Design, there's a new course that just came out last week, is on design in Power BI. You can see that also. The learning in Power BI. The last link was me putting out every
Just a
link.
question. Are
Yeah.
you showing your slides or are you showing your Power BI?
Oh, I'm showing my slides.
No, no, so switch to your slides because we're
Oh,
seeing
okay.
your Power BI.
Oh, okay, cool. So that's why I was asking earlier. On. Okay, fine. Um, Okay. So now the first link is showing DAX in Power BI desktop, and you see the data I use right now. You see it's there. You can just copy it out and you use it. The design in Power BI is a new course in Microsoft Learn that just came out, so you can click on it and just use it. We have learning Power BI. That's also, I put in all the old links that you need to use to learn Power BI. If you're just starting Power BI, you have all the whole links there, and you can also pick it up, check it, and you can use it. Thank you very much. I hope you've learned something new. I hope you learned something new. Thank you very much.
Thank you very much for speaking. It looks like really powerful stuff. That it's like Excel on like Power Excel. So
Yeah.
really, really cool. I'm just going through the questions here. There doesn't seem to be any questions. It could also be that we have people sitting in the dark and not being able to
Yes, I
actually
understand.
ask questions, because yeah, we're busy with our load shedding at the moment, so most of the country's in darkness. So I suggest that, well, people will watch this recording afterwards, and they could post questions to you via Twitter or something like that. But
Yeah,
yeah,
yeah.
but thank you very much for the session. It was really, really cool. Learned a
Thank
lot.
you very much. Thank you for inviting me.
Yeah.
Thank you.
Yeah, no, thank you very much.
Yeah.
Okay, and then Matthew, are you ready for your session?
Yes, adding
Yes.
myself. Let's see. Share my screen. That on. Okay, I think we're good. Let's go with it. All right. Oh, that was nice. Thank you, David, teaching us basically how a financial person might want to look at their data. So, let me get the side screen up there so I can actually see what I'm talking about. So, right, for those who don't know me, I'm Matthew. I write some code at Microsoft, working on the Maui team, and one of the side things I do is SkiaSharp. I like the library. I really enjoy working on it, and I just want to make it work everywhere. So I work on the side on that, as well as I have to do that for the job as well. So I got no real life. Um, but I thought, like, I like to show off like how I made the library work on Blazor, because you have to do some cool things, and that will, I'm hoping, will help everyone out there who has something they need to bring to Blazor to run, let's say, a game engine on the web, but basically, like, maybe this can help as well as give you some ideas or just have some fun learning. So what we're going to talk about today is basically doing native interop, right? Crossing the boundary between writing C# code to maybe JavaScript. And let me go to the next slide there. Basically going to JavaScript, which is a native for the web, right? Before there was any other language in the browser, there was JavaScript. And we're going to have a look at some basic interop with that, as well as have some interop with C++. And this is the new feature that came with Blazor Web Assembly recently, I think in the last preview. So really exciting. You can now bring a C++, game engine, graphics library or something and plonk it on the web and just have it run there. So no need to rewrite the code or port the code from JavaScript. I know there were some cool engines and people ported them to JavaScript, but nowadays just compile directly for the web. So starting with some JavaScript. So maybe before we talk about JavaScript, for those who don't know, Blazor is basically allowing you to make web apps, and Blazor is one way of doing that. So you would maybe know ASP.NET has, like, MVC, or back in the old days, web forms. So Blazor is a new sort of reimagined, sort of based on all the learnings of the past, to come up with a new framework that's very familiar, but also got some cool features, allowing us to basically have client-server interactions. So your server manages stuff, and then the user does stuff on the client, and it sends messages back and forth. But they also have a model where basically, ship the whole server to the client. So that's what we're going to be looking at today. So you compile your entire server application, and it gets bundled and placed on the client. So when the client's navigating or doing things, it's all happening on the client machine. And this is really great to offload work from the server onto the client's machine. And, you get the user to do the carry the cost of a thing, and you can host your entire website, your entire enterprise application, maybe in like blob storage. So that's pretty cool with Blazor. And one thing when you have a website running in the client, right, you need to interact with things like JavaScript. And what Blazor has done has made it really easy to do that. So I'm going to show you a little snippet on screen. As you can see, let's have a look at the JavaScript first. It's pretty simple. I got a little bit of JavaScript there, and I'm popping up an alert, right? So the contents of the function doesn't really matter, but this one is a function that takes a message and pops up an alert with an extended message, right, to make it look exciting. So let's just say this was some massive library out there. I don't know, let's call it chart.js, or I don't know, calculator.js. I'm sure there's a something, or even like carrots.js. Now, JavaScript people like to use random words. So let's say you got that massive function. This might, as I said, it might be anything. And you are on a page and you want to call that JavaScript. Well, if we look at the first bit of C# there, it's really simple. It's really just the bottom line. But the first line, what is happening is we are asking Blazor to do some magic and give us access to the JavaScript runtime. So we add a property on our component or our page, and we say, hey, give us this JS runtime, and you put the inject attribute before it, and it will basically say, I expect this to be here when the page loads. And then at any given point on the page, we decide, hey, I want to call a JavaScript function. As you look at the bottom line, it's very simple. You say JavaScript, I want to invoke a void one. There is one without the void, so it's just invoke async for if you expect a return value. And in this case, you pass in the name of the JavaScript function and any parameters. You can put any number of parameters in there. It automatically gets serialized and passed over to JavaScript. And that's it. That's how you can communicate with JavaScript in Blazor, right? So it's super simple, super easy. So if you have a library that you are bringing on board because you've used it in the past and you can't just rewrite everything in C#, well, this is definitely one way to do it. And some things, it's just so much easier just to use JavaScript. So definitely a really exciting way to make a web app. It's on the client in C#. Maybe I should have mentioned that first. Blazor is C#. I forgot totally about that. So those who don't know what Blazor is, it's doing web apps, but in C# and .NET, running on the client as if it was a JavaScript web app. And in that case, we need to access JavaScript because there'll be a library in JavaScript. But one problem with what happens on this slide, right? I'm attaching a function to window, which means it's in a global scope. So if someone else comes along with a different library and calls and sets up a function called show alert, it's going to clobber mine, and that's uncool. Especially, this might happen internally if you have a big website. Unless all the teams are coordinating and knowing like, hey, this is my show alert, is this one, nobody else can use it, and it's got like a register somewhere, it's going to get out of hand. So we have the ability to say, okay, let's use modules, the JavaScript modules. So for example, if you look at the code at the bottom, it's pretty much the same, except that we've wrapped it in this class, right? JavaScript's class is slightly different, but to C# classes, but this still is just basically saying, hey, I'm putting this all in a way to access it, and probably not necessary, but I like to put in a class. That means all the functions that are in the class are not everywhere. They thing, and you can have multiple classes. But then, if you look at the code, the C# code, it's very similar, except that we've got this new line in the middle. We're invoking some JavaScript, and the first function, first parameter is import. And what does this mean, right? This is basically you telling JavaScript, hey, I want to import this file, but store it in a separate context. So the functions aren't available to the rest of the page. And every time you want to access a function, you have to speak directly to this thing that you just imported. So with that line, we import the JavaScript, we get a reference to it, and we keep it on our page, for example. And we just, in this case, store it in module. And then, just like on the previous example, we call invoke, we pass in the name of the method, pass in the parameters. But the different thing is, instead of calling our JavaScript directly, we call it invoke the method on our module. So it's a little bit different, but not so much. And basically what that's going to do is going to go to that module we imported and then execute the function in it. So we haven't clouded up the global namespace, but still it's effectively a one-liner to invoke some JavaScript. So that is pretty cool. So yeah, and that's it, right? So if you have a JavaScript module or normal JavaScript that you just want to execute, it's basically a one-liner from your C#, and you can execute JavaScript, and you can pass in any number of parameters. It gets magically serialized into something that JavaScript can work with. So that's cool, right? You've got a web app, it's running some JavaScript, you click in a button, it's doing some JavaScripty things. But then let's just say, oh, something happened in JavaScript, and now you want to talk to C#, right? You want to talk to your .NET app. You want to talk to your server in your browser, if you will. Well, that is also almost a one-liner. So first off, we need to have a C# method. This C# method could be anything. It could be some amazing processing. Maybe when a user clicks a button, you want to register something on a queue or write it to a database or invoke some web request. Well, you make sure that's statically available. In this case, there's multiple ways to do invoking. I want to show you both. But in this case, we're going to make a static method. And all we have to do is stick on a single attribute on top. As you see, the J is invocable in the top over there. That's basically telling Blazor, like, hey, this method is a special method. Make it available to be called from JavaScript. And that's it, right? No special technology required, and there is, as you see my comment there's a little bit of a way to say, okay, hey, I want you to identify this. So it's slightly different from what you would expect from a normal .NET. Let's say you were going to call a static method in .NET. You would go find the namespace, you would find the class that it's in, and then you would know the method name, right? So let's just call it, I have my app is called my app, and that's my namespace. I have a class called my class, and I have a function called a method called my method. So if I want to access that, I'll basically have to, do my app dot my class dot my function, right, to find that specific one. However, in Blazor, to make things easier for most cases, what has happened is, instead of having that whole specific string, rather it's given an identifier. This is a free text string, if you will, where you can put in any valid identifier, such as carrots or something. I'm going to go with carrots as everything, and you can call that function. So it allows us to override the name of the method. But let's just say we've declared our method, we added JS invocable either by default using the method name or by overriding it with a custom identifier. We've declared that in C#. This magically gets exposed in the JavaScript world, and then we head over to the bottom block of code. It's pretty simple. It's almost a one-liner. It really is a one-liner, but in this case, I'm showing getting the result back. But all we have to do is access some global Blazor object called .NET, and we just call it again invoke method async, and we pass in the assembly name and our identifier or the name of the method and any number of parameters, and that will do all the work required to serialize the stuff on JavaScript side, send it over the wire or over the fence, and call a method in C#. And this can happen at any point in the JavaScript things that are happening, right? Whether it's an event or some loop that's happening or the user scrolling, and you can fire events. So it's really cool. And what's even more exciting is that if the C# method has a return value, you can just access it like using the JavaScript promises. So that's really cool. So this is just a quick intro into using some C# functions from JavaScript, right? So if you have a JavaScript library that's expecting a callback and it wants to do something, and your response to that callback is in C#, you can totally use this method to hand over some JavaScript, hand over C# code to a JavaScript function. But one downside of that, as I mentioned, was it's a static method, right? So let's just say you've got two controls on your page. Do canvases, for example, let's say you're doing a SkiaSharp canvas, like how do you know which one it is? Like, okay, you can pass a reference to itself or something, but that's a lot of work for the JavaScript caller, but also it's a little bit like, okay, what if you've got multiple pages? Like who's tracking the stuff? And you're going to have a massive dictionary somewhere that's all the objects are defined in. So when you get a parameter, you know what to do. So it gets a bit messy. So what there is another way to basically say, okay, I am going to create a reference to a C# object, pass that around, and then basically be able to invoke a C# method from JavaScript, but on a random object somewhere that's happening, right? So this code is pretty similar to what we just had on the previous slide, except that, you know, we now have this extra line in the middle called the dot that has reference to this .NET object reference sort of class. But what's happening is we simply have a way to wrap the instance of the object. So let's just say the first line, I've got some random object. It could be anything. It can be created at any point. It just exists. I mean, we're using it to do something. Then what we want to do is, if we pass that directly to JavaScript, JavaScript's going to try and serialize it, right, to pass the object. But what we want to do really is pass a reference to that object to JavaScript. So that's what the next line does. It literally does the most basic thing that you can think of. It takes the object, it stores it somewhere. We let Blazor manage it for us, and we get this sort of like object reference. It's sort of basically an ID, a little label to say, hey, this is my object. And then we just continue as normal. We pass that object over to JavaScript, and we let JavaScript do its thing. And if we hop over to the JavaScript, well, what's that thing it's going to do, right? Remember in the previous example, let me hop back. To invoke a method in .NET, we just do .NET.invoke method, right? And that would go find the method somewhere in Blazor. Well, in this case, we're doing the reference.invoke method. So that reference we passed to JavaScript, we can now execute methods on it. So this is really cool, a really easy way for us to basically have pages, multiple pages with multiple controls on it. And we don't have to worry about passing around references in the sense of like, oh, here's an ID maybe, and I have a dictionary somewhere with all the items. We can literally pass references to C# objects into JavaScript. So if you have a page, as I said, with multiple things on it, this becomes really easy. And I know this makes life really easy for when I'm doing SkiaSharp, right? You might have multiple canvases on the screen, right? And I don't have to worry about managing anything. I let Blazor manage it for me. So the codes are similar. As you can see, we've got that C# class over there. It's got the reverse text function. It's got the JS invocable. We know about that. The JS line on the top there, .invoke void async. We know about that. And we're passing a parameter, and the parameter could be anything. And it just so happens that instead of passing an object, we're passing a reference to an object. So that is the bit that has changed. So it's pretty consistent and straightforward and really easy to use, and this could be used at any point on a page. All right. So let's hop into some C#, C++. So I thought I'll start off with some JavaScript interop. That's the world we live in. There's JavaScript in the browser, and there's a couple of ways to interact with, call a method in JavaScript, whether it be via just a static method just floating in the sky, or we want to have it in a JavaScript function in a module, or we want to do the opposite and we want to access a C# method. It's a static one that's floating in the sky. We can just call that, or we can access a particular function on a particular instance of an object, right? Super simple, super easy. It's basically a one line here, maybe two lines there. So that is great. However, we want to do about C++, right? We have this massive game engine. It's doing stuff. Maybe it's working with GPU. Maybe it's a machine learning library. It's pretty big. Nobody wants to write that in JavaScript. And even if you did, I mean, who here feels like, oh, I need to use SQLite in the browser. Let me just, port SQLite over and make sure the tests pass and hopefully it's performant, right? That's not a useful undertaking. However, what if you could just recompile it and make it run in the browser, just as is? And that's what has happened, right? We've gone ahead, done that. In the case of Skia and SkiaSharp, I've taken a native library that was running on the desktop and just compiled it for the web. So let's have a look at how we can talk to that. So let's say you've got an existing Blazor app. or a new one, doesn't really matter, and you've done some JavaScript interop, maybe, I don't know, maybe you've got a couple of pages, you've done some navigation, it's all cool. Now you want to bring in this native library, right? So to get started on bringing that, it doesn't really do anything very different. There's no special commands you have to run, but there are a few extra tools you need, right? Because it's now bringing in a different technology. So .NET brings in obviously the .NET and the Roslyn compiler, you know, it can do some stuff. But when you do C++, you have to bring in the C++ tools so that they can all work together. So it's effectively a checkbox in VS now, and that's nice. You've got the tools on disk, and we have to set a property in our CS proj. This is technically optional, because as soon as you bring in a native file reference, it will, you know, automatically do this. But this can be an explicit way of saying, hey, this build now requires native bits. And just like with any other library, whether it be JavaScript, maybe it's a page, you just have to do an include in your item groups, or, you know, you right click on your property and add existing file, as you may have done before in your CS proj, and that's it. And all we have to do is make sure that the build action is native file reference, and we point to a native library, and boom, we have now brought in a native library into our app. That native library is going to be compiled into our code, and we can access it, right? So it's very simple, very easy to do, and you don't have to worry like, oh, what are the arguments for the C++ compiler? You know, is a dash, what optimization level? Like, you know, you don't have to worry about that, right? Super easy to get started. So let's just say we've gone ahead, we've created our app, we've imported this random library, I don't know, game engine 123, or let's talk about today, SkiaSharp. Okay, what does that mean for us? Well, in order to access methods in native code, it is less code, maybe. Well, there's not really code, it's more definitions to do that. So let's just say we have a C function in the bottom right. Doesn't really matter what it is. It's a big cool function. It does some amazing stuff. In this case, it multiplies two numbers, and I want to access that code, right, in my .NET. This is a C++ snippet of code. It's in a library. I want to access it. So we make use of some cool features in .NET. This is way before Blazor. This is old school. As you can see, that the word is DLL import in the attribute there, even though we're not using DLLs for native bits, but it's been there for years. So what we do is we take the signature from the C code. We say, hey, this is the method. We write it down there. As you can see, the signatures match pretty closely. We go ahead and we say, hey, C#, this is the method I want. We mark it as static because C functions in C or C++, in this case, is a static function. And we don't have a body here, but we add this special attribute keyword saying extern, right? This tells you this method actually gets a body from somewhere else, right? So that's it, right? We're almost done. And that's how we define the method for the .NET world. Then the compiler is going to ask you, like, hey, where does my body actually live? You said it's external to me, so where will I find it? And that's where the attribute comes in. It comes in, and you just basically pass in a single parameter with an optional second one. And the first parameter is what is the name of the file that you compiled in. So in the case of this one, it might be library. And the entry point is literally the name of the function in the C++ world. I have a just there for demonstration, but in most cases, your method will be the same name, so you can leave that out. But just in case there's like some weird, you need to do an overloading, or there's some weird character in there, or you don't like the way the C++ people did it, you can go ahead and override the name of the method with whatever you want, and then use the entry point to say, hey, it actually is this one, and you put the weird name in there, right? So with that, we now have a function in C. We've compiled the native library into the app. We've got this internal, external, and DLL import. We've got it there, and then all of a sudden, as far as the compiler is concerned, that's just a normal method. I'm going to execute this normally, and you can look at the first line. All I'm doing is it's just calling it, right? And that is it. This is how you do native interop. No matter what is happening, this is the way to do it. So if you've got a massive library or a library that does one or two things, it's the same way, right? And a lot of the time you can even generate those DLL imports, and that's what I do for SkiaSharp, right? So it's not even any work to do native interop. So let's have a look at a slightly more complicated example of talking about a C++ library, right? I'm probably spending way too much time on this. I hope people find it interesting. I do, but it's not really that exciting. I suppose everyone's coming to see some more exciting games. But just before we get into that, let's just say we got my class, right? This is a massive class. It's part of a game engine. It's got lots of functions and stuff, and it exists in C++, right? This is a library that maybe you wrote or some big company wrote. It exists. Well, all we have to do in order to access it from C# is one of two things, really. We either can use a library like CPP Sharp, CPP, or CPP Sharp, or a couple of other ones to basically generate some wrapping for us that may work, or often at times it's a lot of work because C++ is very different to the way C works. So what I do for SkiaSharp, and what might be the case for you, is that you say, hey, I'm only interested in these few methods and these few types, so let me wrap it. So if you look at the bottom chunk of the code, we've got this extern C is basically saying, hey, the contents in this, treat it as if it was a C instead of C++, which means I can't use the classes. And we reduce the API. So instead of having, classes with public visibility and, if you're passing a class to C#, what does that mean? It gets a bit weird. So what we do is we define our API to be simple types, like void to represent objects, void star, passing values back and forth. And we can do some basic interop. We define our clean API that we want. And in the implementation side, all we do is we do exactly what we want, but we just sort of hide it, right? Should we create a new class? That's cool. And we just return it, right? And when we get the object back, let's say a function for get value, we take that random object and we just cast it back to my class, and we can call functions on it, right? So we effectively have hidden the big class behind a couple of methods. And the reason we do that is that we can take what I just said in the previous slide and say, hey, make the one line change. So if you look at the bottom over there, I've literally copied the code from over here, the new, delete, and the get value at the bottom, and I've moved it over, and I've slapped on an extern and the DLR import. That's it. We don't use void. We can use void star in C#, but in this case, I'm taking advantage of the new type that they've added into C#, which is the NEnt, which is effectively under the hood a void star. So that's it, right? So that's one of the nice things about native interop. You just create your C API the way you like. And then you just what I do for SkiaSharp is I literally copy the C API, I paste it into C#, and I fix the compiler errors about using a void star here, or this type is not found, and I replace it with like a pointer or something, and that's it, right? It's pretty close. You slap a DLR import, and all of a sudden you've got magical access to a C++ library. And if you look at the first 3 lines of the block there, I'm calling, this is C# code, and I'm just calling it as if it was a normal one. And one thing you can see, I'm creating a new class, I'm catching that instance, I'm using that instance, I pass it around when I call the other functions. It's mostly straightforward. So, but one thing you might want to do is, if you look at this previous example, it's a bit, like, okay, look at those functions, they're nice, but I live in an object-oriented world. So you can actually be a nice thing for yourself, or if you're making a library, you just wrap it in a class. And as you can see, in my constructor, I call new. In the value property, I just call get value, and it's pretty easy. And you see I marked it as iDisposable, which means if you look at the first line, I can use the using, or I can leave it off. And with a little bit of extra code, because I didn't implement disposable correctly here, you can use, because obviously there's a few extra lines of code, I don't want to fit it on the slide, but you can let the GC take care of it, right? That's one of the great things about C# is that I can use the garbage collector. So, you can take your C++ library, you wrap it in a very thin C layer, and then you import that into C#, and then you create a C# wrapper around it optionally, and that allows us to basically work as normal. And I do that for SkiaSharp. It seems to be working. And performance is really, really good, right? The crossing the boundaries for these externs is a little bit of overhead, but it's so little it's almost negligible in most cases. So let's see. All right, now for some really cool stuff, let's have a look at a practical example of doing all of this, right? Both the JavaScript and the C++. So let's have a look at SkiaSharp. SkiaSharp is the library that wraps Skia. So Skia is what I believe to be one of the coolest graphics engines out there. It's a 2D graphics engine. It can do anything. I'm going to go there and say it can do anything. Anything's possible in software, and anything is possible in Skia. I'm going to go with, and anything that's not can be broken down into smaller steps that can be done. Therefore, anything is possible in Skia. So the reason I say anything is possible is because you can draw any shape using any set of things using primitives, and you can draw it to any sort of backend, right? Whether this is a software, as in a bitmap, like, oh, I want to render to a file, or I want to render to like a screen, which is technically a bitmap. It's a bunch of pixels that the memory as operating system has allocated for you, and you can draw onto that, right? This is basically a block. You can, in C world, it's malloc, or in the case of C# world, you might do like a new byte array, right? You can render to a byte array, and you can also decide, hey, I would like to render to a PDF document, right? Technically, it supports, in some cases, the Windows's XPS documents. I don't know if anyone uses that, but that has experimental support. That's been experimental for the last 5 years, so I don't think it works, but I think it's going to get new features. But technically, it works, right? So we've got that weird format in there too. And we can also render to the hardware rendering. And this is using, like, running your code that you write. It runs on the CPU. It sends the commands over to the GPU, and the GPU does the work. And this is really cool because we can get ultra high performance in doing operations. This can be using OpenGL, DirectX, Vulkan, or Metal on Mac OS and iOS, or Apple TV. And I think there might be another format, Dawn or something, which I don't know if anyone uses. It's another abstraction around hardware, and this allows you to do anything on any platform using any hardware component, whether it's your CPU or your GPU. It's just amazing. And the really cool thing about this is, even though I'm not a C and C++ or whatever developer, as such, I can do a bit, and that allows me to make this library. But the code itself is written with like performance in mind, right? Because Google uses this on Chrome and Android and Firefox, or WebKit uses it and stuff like that, right? So it's written, like, some parts I've seen, it's just like, oh, we're writing this in assembly because, I don't know, that was cool at the time. It was a fast one, and C++ was too slow. So it's a wide range of languages involved, and it covers all the platforms that you can think of. And it's maintained and used by Google, and they have a team on it. And as far as I'm concerned, they're a team of geniuses because they have done a good job. And I'm going to show you some examples. Before I show you my demo of just some really cool use cases for it. So we talk about Skia. It's a little library that Google wrote. It's used by half the world and can do anything. So what is SkiaSharp then, right? And SkiaSharp is like a 1% part of the story. It's the .NET wrapper around Skia. It supports most of the features of Skia. I exposed most of the APIs that are useful, that I think are useful. If there are any APIs that need to be added, super easy to add. Often just open an issue on the repo. But I have done a little bit of work to make it package it nicely and get it sort of like a drop-in sort of like just a NuGet install. And I've also got the work done to make it run on even more platforms than Skia technically supports, right? So Skia runs on like Windows, Linux, and Mac, and a couple of other platforms. Then I've gone ahead and said, hey, wait a minute, can we compile this for like UWP, the old UWP apps? No, or I'm gonna run it on Raspberry Pi, and I've got a couple of things there is to make it all work and get all the bits going like it runs on Apple Watch. It wasn't originally designed to run on Apple Watch. It's useless to run on the Apple Watch because at like 4 megabytes, you've used up your 8 megabyte quota on the device, so it's not really practical, but technically it runs. And of course, I've decided I've gone ahead and said okay, most people want to just drop in this random view. Now Skia doesn't come with any views because it's not really a UI kit, whereas I've gone ahead and created I want to drag in a SK canvas, as some of you have seen in Xamarin Forms or in Maui or in Android and iOS. You just drag this, effectively drag. I don't know if people drag stuff anymore. You just drag this view onto your screen, and you can just start writing your drawing logic, and not have to worry about life cycle of the view and is the bitmaps allocated and stuff. And this, as we all know, I love C#. It's written in C#, and it's maintained by Microsoft, and as I said, it's my side project. So on weekends when I'm not working, I am working on SkiaSharp and making Microsoft very happy because I do free work. So how does SkiaSharp work? Let's have a quick look at sort of the parts of SkiaSharp so you would understand the code. There's 3 main parts of SkiaSharp. There's a surface, like any sort of surface that you're drawing to. This will be in memory. This will be GPU texture. This is anything that represents something outside of SkiaSharp, right? So GPU textures, OpenGL texture, or DirectX texture, that is outside SkiaSharp. So this SK surface forms sort of a layer to abstract what the outside world is doing and have a common interface for Skia, right? So you don't usually have to worry about that. That's just if you are saying, hey, I want to draw on this random object over here, then you would somehow use this SK surface and use the correct surface for that. Once you've got a surface, right, whether it's provided by the view or you've created it, you get a canvas. And this is where you do all your work. This consists of literally, let's just say 100, I don't know, 100 different methods of operations of things that you would do on a canvas. Let's say you're going to draw a picture in the real world. You would have a canvas, and then you would draw things on it, right? Lines, circles. Maybe you would print an image. Maybe you would move the canvas. So all those operations are available on the canvas. So you would go canvas dot draw a rectangle, and you would pass in your width and your height and your position, and it would draw a rectangle. But then you ask yourself the question, I'm in the painting world. How do I make a red square? Well, that's where the SK Paint comes in. And that's literally a blob of properties that you would set things on, what's the color? Do you want to use anti-aliasing? Do we have a gradient we want to use? What's the size of the font that we're drawing, right? So these 3 components all work together to perform sort of layers of drawing. So you want to draw to something, use a surface. When you got that surface, you get the canvas, and you say, hey, I wish to perform this operation. Then you say, okay, I'm performing that operation. What do we want it to look like? And then you bring in the paint, and you say, hey, I want to draw a red square on the GPU. There we go, 3 components. So pretty simple, and all operations follow the same step of you perform an operation on the canvas and you bring in a paint, no matter what you're doing. So if we have a quick look at a snippet of code, as I said, we create the surface. In this case, oops, there's a typo. The IH info, I better correct that. It should be image info. So we've gone ahead, we create the surface, and it's 256 by 256. It's just a random bitmap. If we were creating a GPU, we would pass in the GPU context as an additional parameter, and it will spin up a texture for us. But let's just say we've got a surface. As I said, we grab the canvas, and then the next 3 lines is us doing some drawing work. So the first thing you want to do when you get a canvas, who knows what was in memory? Could have been another picture. So we go ahead and we clear that. We zap it gone, nice white. And then, okay, we want to draw something. Okay, so as I mentioned, we need a paint object. We go ahead and say, okay, I want a solid red square. So I create a new paint. I make it red. I make it a solid fill. And then the last line, you want to draw a rectangle. You pass in the bounds. SKRect is just a struct or a rectangle in normal drawing one. It doesn't really do anything exciting, so it just defines the rectangle, and we pass in the paint. If I was going to do a circle, you'll do draw circle. If I was going to draw an image, I would the first one will be slightly different. You don't need the paint, but you would still have the rect, and you would say, hey, draw this image. You know, I want to draw a path. You replace skRect with the path, and it's all the same. You just change the name of the action, and you pass in the different data that you wish to draw, and you pass in the paint at the end to say, hey, this is what I want it to look like. So let's show. See, Lou says it looks complicated, but I'm going to show you it's not. You can do it. Oh, look at that. So I'm going to skip over the JavaScript demos, and let's head over to SkiaSharp. Let's open this one. That. All right. We can minimize that. So if you look on the right, we have a sort of a canvas here with some text on it. It doesn't do too much. But if I click and do some wiggly, look at that. It follows my cursor. I let go. It zaps to the beginning. All right. So how does that work? And this is where I'm going to show two different things about Blazor. So first off, this is normal HTML for those who know HTML. So you're making a Blazor app. It's HTML in there too. It's with a C# at the bottom. And I've gone ahead and, as I mentioned, SkiaSharp comes with a bunch of canvases and views. So I go ahead and plonk this SK canvas view on the thing. It just fits in with a normal HTML. And under the hood, as using a normal HTML canvas, nothing too crazy. And these, for those who know Blazor, this is just a Blazor method, and this is actually a Blazor way of getting a C# method onto a sort of HTML. This is a normal HTML thing. So if you were doing another, like, I don't know, let's just call it a div, then there'll be the on point. No, I don't know, which one is it? Is it canvas? Oh my gosh, canvas dot on point. I don't know how this works anymore. Why is it no? There we go. Anyway, so you have a whole bunch of these attributes that you'll stick on elements, and just like with the thing, I think you like in a it's on click, right? So if I do div, let's say you want to make you want someone clicks on a div, then I believe they're on click. I don't understand Java. I don't know really HTML, to be really honest. I know C#. This is why I would use Blazor, right? So I want to add it on click, and then you would have some sort of JavaScript function that you would define in JavaScript. However, we can just still bring that along. So if you're a web developer, you can hop into Blazor and you still understand the HTML on the screen. And if you're a C# developer, just a little bit of learning to do the HTML, just as the someone would coming from a web would say JavaScript would have to learn a bit of C#. Well, once you learn that, you can just use all the normal stuff. There's no weird and fancy, custom frameworky things. We go ahead stuff, and let's say we've got a canvas and you want to draw on it while we've done our stuff, and we go ahead and we attach this single event in to do the painting. We attach that, and this is where we do our drawing. And also, as you look at these other ones with the down, up, and move, I go ahead and I basically just move the touch location. So when a pointer comes down or the pointer moves, I just update the touch location with the cursor position, right? So nothing too exciting over there. And obviously, every time you do something, you tell the view, hey, time to invalidate. You've got old data, and it will go ahead and refresh. So as you see with the drawing code, it follows the same as the slide. I've gone ahead and grabbed a canvas. I clear it white. We can make it go red here. Let's see if Hot Reload's happy with us. Oh, so the tick box. Oh yes, I updated the code, but because it's I've got to update it. So click. Yay! Right. So pretty cool. Let's go Azure, because that's where we love our stuff runs in Azure. And we want to make the text. I don't know. Let's make it green. Let's make it outline, to be honest, or stroke. Let's make the 4. And of course, we want to make it when it's centered to be the third, right? So instead of being in the center of the screen, we want it to be the left third of the screen, right? Pretty cool stuff. And let's call this Cape or CPT MS Doug. Let's do that, right? Because I'm in Cape Town, and Cape Town's cool. Look at that. Yeah, look at the hollow green text, right? Super easy. And it looks all exciting, and it's pretty good. Nothing too exciting happening here, but we can pretty much do anything we want. Let's draw. You know what? Before we draw, let's jump over to something even more exciting. Right? So let's hop over to the GPU. Same concept, and it allows us to do even more hot reloady things. So again, we've got a GL view, right? Because in this case we're using WebGL. I've attached my paint surface event. Also enabled a render loop, right? That's why this thing's ticking over at high speed without having to click on it. So pretty much the same. In this case, I was having events. So when you touch stuff with a cursor, it would refresh. In this case, I decided, no, scrap that. We're going full-time refresh. So we're refreshing. And of course, I've attached this massive paint method that basically draws, let me zoom out one level. It goes ahead and draws this thing. So I start off as usual by clearing the canvas. Now this stuff is just to get some defaults in, like the canvas size and the current time because we're going to use it. So nothing particularly drawing related. I go ahead again, create my paint object. Remember, we need to have a paint object. So in this case, we're going to draw the background. So we've gone ahead, we say, hey, you want smooth things, you want a default stroke, you want the ends to be round. If I make it, default font size, just setting up some defaults because it's cool to do that. And then I go ahead and draw some text. And again, at the end, you can see there's the paint object that says, hey, draw the text using these properties. And I can go in here and I can say, frames per second, right? I don't know. Boom, done. Let's put a space there. Okay, that's pretty exciting. Let's move this width to the, let's do that, right? Cool. Let's not stick on that. And then, of course, I'm like, okay, I want to draw a gradient, right? I want a nice shading, and I go ahead and I create a shader. First line is, the starting point. So when you draw a gradient, it's going to draw, let's do this. Let's show you where it goes. So we go canvas.draw circle. Cool. And we're going to say, hey, draw a circle at 0, 0, make it 5, and do paint. Oh my gosh. That was weird. 0, 0, and the radius of 5, right? Can this work? Type. I'm missing something. IntelliSense is saying I'm bad. No. However, that. Canvas. There we go. All right, there we go. See the little red black dots over there, and let's do another one. Let's copy this, and I'm going to show you where the points are. So I've gone ahead and I'm basically making a gradient from here to here, and I'm going to plonk it onto the screen inside the circle, right? So that's what's happening. So I can go ahead and make this. I don't know. Let's make this 20, and let's put a dot there so you can see where it is, and you can see the gradient has moved a bit. So we can go ahead and say, hey, I want to use 3 colors. SK color. Let's use some cool things. So we cast this to SK color, and we like to use, hex notation. So let's make it red, green. Let's make it green, right? Should be cool that way. Look at that. So we go from gray, red to green, and we're basically saying, draw the gradient. So we can go ahead and draw anything we want. I don't know, maybe we like create, let's do gradient. Let's make it a radial gradient. I forget what the parameters are. We need a center and the radius. Okay, so the center, let's copy this because we want it to be centered on the screen. So we go there. Let's say, hey, divide it into 2. And the radius, let's make this radius, I don't know, what's the radius of that? Clock size, let's do that. Let's copy that. Okay, so I've gone ahead and changed from a linear gradient. And I think this is correct. We shall find out in a second. Okay, I've got to put a point. Escape. I got my, oh my gosh. There's bad things happening. What is that? Escape. So I've gone ahead, I'll say I want my center of my gradient to be in the center of the screen. I want to use whatever this number is as my radius of the gradient, and these are the colors I want. And something's telling me I have done everything wrong. Oh, there we go. Look at that ghastly gradient. Okay, so it's pretty cool. And of course, the way I'm doing some scaling, if you look over here, I'll go ahead and I decide, hey, I'm going to rotate the canvas over here for the hour hand, which is the small one here. I go ahead and say, okay, I want to save the current transformation. I don't care what's happening. Save the state of the canvas. I'm going to move the canvas. And you know what? To make things even more exciting, let's delete all of this. And let's show you something. So if I go canvas.draw rect, we saw this before. Let's say, hey, sk rect dot create, and let's just draw it 0, 0, and oh my gosh, I type in 0 and then it does that. 0, oh my gosh, 100, 100, and we're going to use a new escape paint, and let's call this color equals escape colors red. All right, fingers crossed. There we go. All right, so I've got a red canvas in the thing, and let's just say we wish to move this around, right? As one word, like nothing's ever drawn in a single position. There is one way. Let's say I want to put it just off a bit, like 50 by 50 from the side, right? We could do the math. Some people might want to do that, and let's just say you wanted 3/4 of the way in. You could do math on it, and then say you got a square and a circle next to each other. Let me demonstrate that. Let's just say you want this, right? Your image, believe that. There we go. This is a cool shape. Now you want to move this across. Let's say centered. You're going to have to go ahead and update all of them, and that'll be crazy, right? So we can just go ahead and say, hey, canvas, just move yourself. So let's go ahead and move this thing over 50 to the right. Boom, right? The problem comes in is if I go, okay, I want to draw something on canvas dot draw. What do we want to draw? We want to draw, I don't know, let's draw a line. Look at that, cool. I want to go the line to go from 0, 0, right, the top left, and I want to, oh my gosh. IntelliSense in Razor is crazy at this moment. And we want to go, let's just draw a diagonal line, and we want to go 50 to 50, right? We want to draw a line, and let's do a new escape paint, and let's call this color, and we're going to do escape colors dot, I don't know, blue. There we go. Let's make this green, so we can have a green circle. Right. So we can have a red block, a green. So what we expect. We expect, oh gosh, let's make that stroke thicker. Again, as you can see, what I'm doing here is I want to draw it, and I'm going in the paint object, and I'm updating sort of what I want the thing to look like. And let's make this 10, right? So everything that you do, there we go, beautiful. So we got that, but that's not where I wanted it, right? I wanted this to be 0, 0. So like, oh no, and I have to do like minus 50 all of a sudden. Or I could say, okay, oh, I know how to do this. I've learned about this translate. Let's move it back. Phew, all fixed. But now you got to remember to do that. So this is where it gets even cooler. Canvas dot save. It doesn't save the bitmap pixels. It saves more the transformations and the styles and stuff that you've added. And you just do restore. Go ahead. And this does some stuff. I said I was going to show off even more cool examples before I do my demo. Look at that. It's back there, but I didn't. I lied. Oh dear. Let's just say I had to show you guys rotate. Let's say we rotate degrees, and let's make this 45 degrees, right? Look at that messy thing. All right, let's do the line then. All right, let's do that. Now, okay, there's rotating. It looks cool. Okay, so we're doing some rotation. Let's make it animated. So first off, let's just make this. Let's abuse this quickly, this random method, because we know hot reload's running. We make that 0, and let's delete all this. We don't care about that. Let's do that quickly, and then of course we do plus. All right, and let's do that. Okay, it's going over there. Let's move this thing to the center of the screen. Over here, some weird thing. Translate. There we go. Look at that. Right? We can do animations. All we have to do is just recall the paint method, and we got this, and we got this object we've offset, and we've decided, hey, you know, I want to draw a line, but let's just say we want to go, let's just do SVG path of a star. Ignore the hideous news in the background there, and let's say we're going to do is make this the center of the star to be 0, 0. And let's have a 24 stroke star. I'm just stealing it from the web because I don't know how to create paths in real time. It's too much work. So I go over here and let's call it a var star SVG. And oops, caps lock is on. SVG, and let's make it, just paste that string in there. All right. So how do we draw a path? Well, you can use like a var path is equal to escape path. Now, a path's really cool. You can do anything in a path. You can do a new path, and then you can go like, okay, path dot add arc, and you pass in the arc coordinates. But we are too lazy to do that. You can build up an entire path. In most case, designers will give you an SVG path, so you can go ahead and I don't know, what did I call that thing? Star SVG. There we go. So I magically spawned a path, and let's just draw a path. Let's make that 3, just because it's going to be a massive line. I draw the path, and there we go, the spinning star. And basically, with a whole bunch of combination of various things, you can build up. Let's move this block, and let's just say, hey, we want to do that. Maybe one of the again, we can, I don't know, not really exciting, right? But so I'm showing this using basic. I do some C++ under the hood to make it all work. The layer. I then create an API for you guys, and you guys can go ahead and like, okay, we can write a bit of code. We do lots of commands here to draw a square. Lots of work. I don't want to be involved in that. So you can go ahead and use libraries and things to do something that makes an entire app like this. For example, here is oops, let me refresh quickly. So here is an app on the web that's running, I think, in Uno right now. But this is all powered. This entire UI. Okay, I bet these are the HTML. But like this drawing, right, is powered by SkiaSharp. You can go ahead. We can make. Let's change the color. Oops. Here's a nice little picker. Paint that in green. Oh, wait, I want to draw some circles. So when I'm showing off the basic drawing commands, right, that's just like with any type of shape. Shapes are made up with simple lines. It's like, oh, what can we do with that? And you put it all together, right? You can get a fully featured, powerful drawing engine over here that can do all this sort of stuff. And let's erase this. But we can also make cool, exciting things like here's trains.net. Let's just refresh that because I think the browser has gone to sleep or something. We can go ahead and we can make little games. Let's put a track on here, right? And this is all rendered with SkiaSharp. And let's go around the corner. Come on, that's poor train people. And go ahead and we're going to slap a train on there. Look at that. So this is all built up. Like if you view the source code, like here's rectangles over here. These are individual rectangles. This path is built with arcs, I believe. So when you go from having like, oh, it's just a simple shape, you put it all together and you can do anything you want, right? And what's cool about this, if I run this thing, as you can see, should be getting about 60 frames a second. There we go, 40. Wait for the maths to work out. Come on. Okay. Probably because I have all the other render loops running in the back. No, don't fail me now. It should be 60. I don't know. I'm going to blame David and say, hey, or you can make games like this, right? You don't have to draw anything. Here's based on sprites. You get that Flappy Bird. Doesn't do much. It flaps. Oh, he died so quickly. And all these things. So before I totally forget that I'm actually presenting. So I hope that was sort of a quick intro into SkiaSharp, into C++, and the way the bindings work. It's which I'll link to in a second. You can say, I would like to use that for SkiaSharp. I've gone ahead and done that. And then you guys can come along, and you can say, hey, I've got this app I want to create, of this game I want to create. And you can write the lines of code to to make your game or your app, and you can use the power that Skia brings. Because it's now running, a C++ library is running in the web, you can create anything that you desire. And yeah, I think I went incredibly over time. So I'll post those links. This link is the link to my repo with all the demos that I got there. And yeah, and then obviously the links to the examples apps that I was showing off. But you definitely can go check it out. Maybe we can hook it into Blazor. And yeah, thank you very much.
That was really, really awesome. It's great to see like .NET appearing in a browser and interop happening with JavaScript and stuff. It's just like magic.
Yeah.
Yeah, just a question on that, on the interop. Is there any guidelines that you can follow for performance? Like surely between JavaScript and C#, there must be some sort of guidelines for performance in the interop. Things
I'm not
do?
Shouldn't you do? I suppose one thing to realize is that every time you call a JavaScript method with a whole bunch of arguments or parameters, it actually has to serialize it. So it converts it into a JavaScript version of the object. So if you're doing that a lot, you may want to maybe cache it on the Java side and then update particular properties later. No, because that might be something that will take a lot of performance, as well as in the case of WebAssembly, it's happening on the client. Everything's happening in the user's browser. But if you're doing Blazor JavaScript interop from, let's say, the server module, it's actually got to send all your JavaScript stuff across the wire. So, if you call a method in JavaScript, it's got to go across the wire. So you've got to be careful that the stuff that you think you're calling, I'm just accessing a method in JavaScript, quickly, might not be as quick, right? Because if you call a function in JavaScript from the server, it's got to first reach the client and then be executed. So if you're doing something crazy in JavaScript and passing a massive data set, you may want to store that, because the next time you call it, like, well, just pass the data. I've cached it locally in my C# code, but because the code's executing on JavaScript, every time you call the method, it's got to send it over the wire. So you might want to think about how you're hosting your Blazor, and you say, like, okay, it's on the client, I can cache it on the client, but if it's on the server, then you're like, okay, I've got to make sure that this gets to JavaScript and then cache it there. So that'd be one thing.
Server round tripping and things like that.
Yeah, no, you don't want to send a database across the wire every call.
No, definitely not. No, cool. Thank you very much. Yeah. I'm just checking here that there doesn't seem to be any questions asked. But yeah, thank you very much. That was a really awesome session. But yeah, I just love to see C# in a browser.
Yeah,
that
C# runs amazing. Everywhere now. I don't think there's places that C# or .NET doesn't run. I mean, I know sometimes we recently, relatively recently, we add support for C# on like the IBM 360 or the X360 or some Spark 360 or something. There's some random CPU format that some company has, and Mono runs on that. And I don't know, crazy people out there, custom enterprise hardware tech. That's pretty crazy. Just it's everywhere.
Anyway, Mono run. so yeah, that's pretty awesome. Cool. Yeah, thank you very much. I think we can wrap up for the night. It's getting quite late. So let me just do the closing speech. Hopefully everyone's going to hear this part. We didn't do so well in our intros, but yeah, hopefully the audio is working for this one. Let me just share this. So everyone, thank you for attending. I know it's late on a night with lots of load shedding and technical problems. But thank you very, very much for attending, and thank you for the awesome speakers. Thank you to David, and thank you to Matthew for awesome topics, and sharing their knowledge with us. Everyone has something to speak about. So please, if you do have a topic that you want to present, we have sessionized for the Cape Town user group, and we also have a sessionized for Johannesburg. Please submit the talks, and hope to see you speaking next time or next month at the MS Developer User Group. But thank you and have a good evening.